The noble gases are found in group 0 of the periodic table. There are 6 elements in this group: helium, neon, argon, krypton, xenon and radon. Their position in the table means they have a common electronic structure. Helium has a full outer shell of electrons, as does neon. Going down the group, there's always a stable outer shell of electrons. This makes the noble gases very stable and unreactive, which also makes them extremely useful. Perhaps the most familiar use of the noble gases is in glowing neon signs. These are lamps usually constructed from clear, colourless glass tubes. The tubes are filled with neon or argon, or a mixture of both gases. To start making a neon sign, the glass tube is very skillfully bent into the right shape. Next, an electrode is fitted to each end of the glass tube. Finally, the noble gas is introduced at very low pressure and the tube is then sealed. When an electric current is passed through the gas, light is emitted. Even at high current, the gases don't react, so these tubes can last for up to 30 years. Pure neon produces orange-red light. Argon produces a blue-green light. Helium produces a pale pink light. A whole array of other colours can be produced by using tubes with fluorescent coatings. Argon is used in fluorescent tubes for sunbeds. Under the right conditions, an electric current passing through this gas produces ultraviolet radiation. Because argon is a very unreactive gas, it's also used in welding. The hot welding metal is surrounded by a flow of invisible argon. It prevents the metal from reacting with oxygen in the air. Deep-sea diving is one of the more surprising applications of a noble gas. Helium is sometimes used in breathing apparatus. Pure oxygen can be toxic to the human body, so it has to be mixed with other gases. The air we normally breathe is mostly a mixture of oxygen and nitrogen, but some deep-sea divers use a mixture that also contains helium. This allows them to dive to greater depth for longer periods of time. So far, we've looked at the chemical properties of the noble gases, but their physical properties also make them useful. Take density. This airship can float through the sky because it's filled with helium gas. Helium's less dense than air, so the airship rises upwards. To compare the densities of the noble gases, we're going to use balloons. We know helium is less dense than air. No surprises, the helium-filled balloon rises. This balloon is filled with neon. It slowly sinks to the ground. Neon is more dense than helium. What do you predict will happen to other balloons filled with argon, krypton and xenon? Xenon sinks the fastest. Krypton takes a bit longer, followed by argon. The noble gases become more dense as you go down the group.